Alright, hi guys. So in this video, I'm going to basically talk about the answer of the practice paper. So before you go through the video, please pause the video, and I should have attached a PDF file in the description below where you can refer to it, and then you download it, finish it, and then you go through the video to look for the answers, okay? And actually this is a regular lesson. As you can see, your friends are over here. So you see, Mr. O-Level let you down, never leave you uneducated, all right? So I hope you first finish the paper and then you go through the rest of the video, all right? So let's get started. So guys, okay, back to a regular lesson. First, check the multiple choice answer, especially over here. So, cannot be, can I magnify it in a red recording? All right, yeah, so it should be A. A, come on. I only spend like half of the time, okay? So to check whether you focus or not. So now that should be the correct version. Okay, please check the answer. Oh, this one, I understand, because you may think that for the second question, you may think that the rechargeable cell, the nickel metal hydride cell, should have the longest discharging time. But in fact, the characteristic of rechargeable cells such as a nickel metal hydride cell is they maintain a relatively constant voltage, but then it has a sudden drop after some while. So actually, Z should be the nickel metal hydride cell. And why? It should have a gradual decrease in voltage over time. So this is NIMH. This is this is the alkaline manganese alkaline. Let me put it down. This is NIMH. Right. This is zinc carbon. So yeah, it should be C, right? What did I put down? D. Oh, it's just face. It should be C. Okay. All right. So let's continue. Let's continue. Just to check. All right. Let's continue. Too much things cloud my mind. Okay. Let's continue. Any other problems you have come across? Okay, so question 10. Question 10, this is so this is a chemical cell. We have the aluminium and the household bleach, and it says that electron flow from the aluminium can to the carbon rod. So this kind of tells you that aluminium undergoes oxidation. All right, so Al become Al3 plus and 3 electron, and because it's oxidation, must be NO. So the first statement is already wrong. Okay, aluminium can should be the anode instead of cathode. Oxidation occurs at aluminium can must be correct. So if one is not correct, okay, only B or D. Now 3 here, the ionic half equation for the chemical change. So if you realize that this equation by itself, you see the electron is on the right hand side. That means no matter what, this is oxidation, right? But you know that for carbon rod, it should be the cathode, it should be reduction that's taking place. So this is not correct. Right, so number 8. Okay, number 8 is actually quite difficult. So for number 8, so we have 3 different species, and the question is asking to arrange the order of increasing oxidizing power. So basically, we want to arrange them according to the readiness of undergo reduction. So we want to have the one that like to undergo reduction the most being on the right-hand side, and then something like that. So if you have ClO2 and Fe, ClO2 and Fe, there is a reaction. So that means ClO2 undergoes reduction, okay, undergoes reduction. So, and based on what we have discussed before, based on this fact, we also know that ClO2 likes to undergo reduction more than Fe3+, because after the reaction, it forms ClO2- and Fe3+. If Fe3+ likes to undergo reduction more, then the reverse reaction should proceed, right? But that is not the case. That means Fe3+ is not really prefer undergo reduction when compared to ClO2. So based on this, we know that ClO2 likes to undergo reduction, and therefore it's a stronger OA when compared to Fe3+. Okay? So at least from this, we can tell ClO2 bigger than Fe3+. Do you get it? Do you get it? Do you get this logic? Now, the second experiment, PbSO4 and Fe. So in this case, no reaction. So that means PbSO4 don't want to undergo reduction. So if it's not going to undergo reduction, it should be a weaker OA, weaker than Fe3+. So in the second observation, we know that Fe3+ has a stronger oxidizing power than PbSO4. So altogether, so you should choose. Did I make it wrong again? Yes, this is the increasing oxidation, so this was strongest. So it should be boy. What did I choose? Boy, okay, correct. Oh, I tried to be so, what, okay. I don't want to say that. Okay. All right, so anything else? Need to speed up a little bit. Some questions are easy, so I just quickly show you the answer, and I don't think I need to explain. All right, so I just show you the answer for the first question. Should not be too difficult. Now the first one is, actually, whether they are redox reaction, all of them are redox reaction. Identify, so no need to explain. So net ionic equation, the first one, just a displacement reaction, should not be a problem. For observation, you can say zinc metal dissolves because I already mentioned here zinc metal. Or you can say, well, if you say silvery metal dissolves, also okay. Silvery solid dissolves, also okay. All right, so the next one, chlorine water add to sodium iodide. You actually have done this one before. So there should be a color change from colorless to yellow or brown. Colorless to yellow or brown. Because iodine in aqueous solution should be yellow or brown. Okay? Okay, and C. This one, I think you guys have done this one before. Yes, not really difficult. So sulfite will be SO3 2-, and it becomes SO4 2-. Now, if student at the back you want to move up, you can help yourself. But yeah, I missed out the observation. Sorry. So the color changes from purple to colorless or very pale pink. And this is also the reason why they said excess potassium sulfite, that ensure that all the purple permanganate has been converted into Mn2+. Otherwise, no obvious observation can be observed because really intense purple color. Okay. D. So D is the reaction between nitric acid and elemental sulfur. That means sulfur. Okay. So you know, nitric acid is an oxidizing agent, so it can oxidize sulfur to SO2. Okay. So should not be too difficult to balance. Yes. I said only corn. I mean, did I say no reaction with dilute nitric acid? So I think that should be a reaction. Okay, maybe slower. Okay, but still be a reaction. Okay. So we produce SO2 and NO. So you can say brown film because now NO by itself is colorless, but it can further oxidize to form NO2. Or you can say yellow solid dissolves because sulfur is yellow in color. So after the reaction, it dissolves. Okay. Question 2 is very easy. Just to contrast, to tell the difference between corn sulfuric acid and nitric acid using a metal. So a good choice would be copper. So you add a correct metal, that will be 1 mark, and then you tell me the observations. Now, one trick of using the observation when dealing with this question is mentioned only corn nitric acid give brown film. Now, this word only means that the other one has no observable change. So that can save many time. You don't have to say corn nitric acid give brown film, corn sulfuric acid has no observable change. That can save you a lot of time. Okay? Okay? So 3 marks, no problem. So next one is about chlorine. So it says that we have something called thiosulfate, and reacts with chlorine to produce sulfate, chloride, hydrogen ion. Okay, it gives you a lot of hints already. So oxidation number of sulfur in this reaction. So you know sulfate is SO4 2 minus, huh? So it's from positive 2 to positive 6, right? And the change in oxidation number of chlorine, so from chlorine to chloride, 0 to -1, easy. Now the ionic half equation for the chemical change for sodium thiosulfate. So for thiosulfate is S2O3, sorry, so small here, S2O3 2 minus to SO4 2 minus. So first of all, you balance the sulfur, so you have to put a 2 here, because there are 2 sulfur here, and then you balance the oxygen. So oxygen on the right hand side 8, on the left hand side 3. So you put 5 H2O on the left. And as you put 5 H2O on the left, you got 10 H plus, 10 hydrogen atoms. So you add 10 H plus on the right hand side, and then balance it with 8 electrons. Okay? And you can double check, cross check, because each sulfur atom, okay, as it oxidizes, it changed from positive 2 to positive 6. So it has lost 4 electrons. But there are 2 sulfur atoms, so altogether lost 8 electrons. We can always cross-check using this technique. Right? And then, ionic equation, thiosulfate, chlorine, you just combine the 2 equations, then you should have something like this. Just combine 2 half equations. It should not be too difficult. Chloride, the reduction of chlorine should be easy to deduce. Okay, and the last question, very, very good actually. It says that, iodine can also react with thiosulfate, according to this equation. Right, and then they ask you whether chlorine or iodine is a stronger OA, based on the reaction. Now, actually, based on your existing knowledge, you should be able to tell chlorine is a stronger OA, right? Simply because chlorine is more reactive, right? So the first mark, you should be able to get it. But as to the explanation, this one may be new to you. Sorry, so small, but I cannot magnify. So the trick is to make it closer to the camera. See, so clever. Now, I would say, if you look at chlorine, you see it oxidizes thiosulfate to sulfate. So the oxidation number changed from positive 2 to positive 6. Actually, positive 6 is the highest oxidation state of sulfur, if you reckon. Because sulfur has only 6 outermost shell electrons. So basically, it has snatched all the electrons from sulfur. That's the best it can do. That's the most highest oxidation state sulfur can attain. So, but then if you look at iodine when it oxidizes the thiosulfate, it becomes S4O6 2 minus. And you realize the oxidation number of S in S4O6 2 minus is only positive 2.5. So the extent of oxidation is lesser than that of chlorine. All right? So this is why chlorine is a stronger oxidizing agent, because it can completely oxidize, fully oxidize, or oxidize to a greatest extent. Okay? Something like that. All right? So that one may be challenging for you guys, because maybe you haven't seen this type of question before. Okay? So just use your language to explain this up. Okay? Not much time left, need to rush. Okay, why chlorine is undesirable? Because it's toxic, it's irritating. Okay? Disproportionation. Do you remember this reaction? One species undergoes oxidation and reduction at the same time. So basically, you just tell me when ClO2 undergoes oxidation, how is the oxidation number changes? When ClO2 undergoes reduction, how is its oxidation number changes? Okay, easy, easy. Do you get it? Do you get it? So it's like when ClO2 undergoes reduction, so it forms this one up. So it is changing from positive 4 to positive 1, okay? Because O should be negative 2, right? So similar idea. This one is positive 4, but this one is positive 5, okay? Okay. Comfortable, okay. Next one. Again, chlorine bleach. Really like chlorine bleach. But this one, you come across a question asking you to balance half equation using in alkaline medium. So oxidation number of this one, again, positive 1, okay? And oxidation of chromium metal. So in alkaline medium, you see alkaline medium, very important. So you cannot use H plus H2O. And plus the fact that it does not form Cl3 plus only, it forms this complex ion. So you have to follow through. But I think it should be quite obvious, right? It should be quite obvious. You don't have OH, but you can add OH minus. So you should add OH minus to balance. So just like this. All right? And you add 3 electrons to balance the charge, plus the fact that this is oxidation. And for the reduction of hypochlorite ion, it actually gives you a lot of hints from the top. So it gives, so you see here, a lot of hints. Chlorine bleach undergoes reduction in the presence of water to form chloride ion, hydroxide ion. So a lot of hints has already been given. So like I said, will they ask you to balance the equation in alkaline medium? The answer is yes, but usually they give you a lot of information in order to do it. Okay. All right. So this is the case. All right. And an electron flow from chromium to carbon rod, anti-clockwise, something like that. Okay. Now, for this one, you cannot say from anode to cathode because it must be true. Okay? You cannot say from anode to cathode. It must be from which metal, which electrode to which electrode. So the part D is kind of out of syllabus. It's about the collision frequency. So with a higher concentration, the reactant collide more frequently on the electrode. Okay. Not really chromium. It's the carbon electrode. Okay. Okay. I still got one part here. Oh, this one. This is a very simple test. First of all, they ask you to transcribe the word equation into chemical equation. So a lot of you just too naive, just put down the chemical, but forgot to balance. Okay, because it's 2HCl. Okay, in order to balance the equation. So not only just to transcribe the English into chemical formula, but you also have to balance the equation. What else? Observable change. So you know that chlorine gas is produced. So it goes up and then dissolves in here. dissolves in here. So when chlorine dissolves and come across the potassium iodide, just like the previous question, it will undergo a redox reaction to have iodine form. So the iodine will dissolve in the water to give a yellow or brown color. And to explain the observation, so chlorine basically oxidizes iodide to iodine, right? Okay? Maybe just a little bit. You guys come up later, so that's why, despite I arrived late too. Okay, just maybe 3 more minutes, okay? So the last question, actually quite easy, right? Actually the last question. So this one is an inert electrode cell. And you look at the left-hand side, you see dichromic, already know, very strong oxidizing agent must be the one that undergoes reduction, okay? You see Cr2O7, 2-, always see this one, right? Strong oxidizing agent must undergo reduction. So this one reduction, this one must be oxidation. So our only equation on half pKa, then that equation should be written many, many times, right? And then in terms of oxidation number, is this an oxidation or reduction? Of course it's reduction because change in oxidation number of Cr from positive 6 to positive 3. Okay? And ionic half equation, so sorry, this one, duplicated, okay? Because I just done this one like this morning, okay? Duplicated, but doesn't matter, you can still go through it. So on the beaker B, the Fe2 plus undergoes oxidation to form Fe3 plus. So direction of electron flow from B to A, anti-clockwise. 2 observation. So you know that on beaker A dichromic becomes chromium 3. So you will expect the solution become green, right? So, but what is the color at the first place? So you have orange, you have green, mixed together gives you yellow. So yellow to green, okay? Right? And then this one, maybe yellow plus green gives you greenish yellow. Okay, so from greenish yellow to yellow. But I think for this question, I focus on the resulting color because, well, quite difficult to tell what is the color of a mixture. Okay, so I will focus on the resulting color. So for B, should be yellow or brown, A should be green. And the last question, I have talked about it before, why sulfite cannot be used as a salt bridge, because sulfite is a reducing agent. It will obviously reduce dichromic ion. Okay? Okay? Okay, any problem? Any problem? Any problem? Now, if you have problem, you ask me during recess or later, okay? So that's it for today. Bye-bye.